Hi, folks. Well, the Boombots are coming together, and I'm starting to get emails from students and students dropping by my office and saying, Jason, the motors aren't turning. And so I thought I'd gather up my trusty troubleshooting tools and walk you through the process of some of the basic troubleshooting steps you can take that 90+% of the time will get your motors turning really nicely. So I've got my cup of coffee, a multimeter, or equally as good, where's that camera gone? A DP scope. Okay, for those of you who are in technology teacher education at BCIT, you will have made a DP scope and have one kicking around the house, so you can use that in lieu of a multimeter. And a box of Kleenex, because there's probably going to be lots of no, we're not going to cry. We're going to get our motors up here and we're going to get them running. And so let's dig into our Boombot right here and take a look at things that we can do. Now, before we jump in, this is starting to get to be a complex project. And it's one of the reasons that I really like robotics as a learning opportunity for students, because it combines multiple things that can possibly go wrong. Usually when you're dealing with a mechanical system in woodwork, you're trying to get a joint to fit together. There's one thing that can go wrong. The joint doesn't fit, and you've got to take a look at it and you can see what's going on. But in electronics, particularly when we start talking about robotics, we start to combine electronic, okay, so the actual physical components and connections, software, the code that we're running to make things happen, and the mechanical, the actual motors and connections and wires and everything that we've got on there all together. And if you try to troubleshoot that as one huge ball, you're going to be troubleshooting this incredibly messy combination of things. You really need to break it down into individual steps. And of course, in the process of breaking it down into individual steps, you need to have an overall picture of what it is that you're trying to accomplish and what the big picture looks like. But within that big picture, there's individual tiny little things that we can test. And I want to sort of break this down into some of those steps. So one of the things that we're going to make reference to is the schematic, and the schematics in the first or second page of the electronics design manual. I'm doing it right here in Design Spark, the program that I use to create it, because it lets me highlight things a little bit more easily. And for getting your motors running, the key part that we're looking for right here is this chip called the L293D. Okay, and it is what we call a quadruple half H-bridge chip, which sounds really fancy until we can probably summarize it as the on-off go thing. And yeah, my mouse is being a little bit fussy here. Let me just drag this around so we can see it more easily on here. So here's our L293D, and of course it recenters. There we go. So L293D all lit right up in there. Now we've done a few things with the L293D to make it work, but the key thing to know is that the L293D is the muscle of your chip, okay? Of your robot. The Arduino is the brain. And what's going to happen right here is basically your inputs are coming in from the Arduino right along here. And so you've got an input 1 and an input 2. Now these two inputs control the motor on one side. So if you set this input high, then this output should be high. And if you set this input low, then this output should be low. So what you should then see is those logic level signals that come into those input pins should result in motor current drive levels coming out from the output pin. So if I set input 1 high, then output 1 should be high but running at your motor voltage and driven by your motor battery instead of by your logic battery. And that should come out right around here and go to this pin, which will then go off and turn your motor around. Okay, so long as the current can get back down here and come in right here. Now, we've built our first troubleshooting step right into here. And these LEDs come in here quite nicely so that we can see if our Arduino is actually giving us a signal out to the pins right here. And so these LEDs should flash on and off, or at least turn on and indicate the status of our input pins, but unfortunately they don't tell us anything about the status of our output pins. Okay, I guess in future I could add another set of LEDs right across the output pins, but I wanted all that power to go down to the motors. All right, so how does this chip do its magic? Well, in order for those inputs to work, you need to have your enable pin turned on, and you can see that this line comes up to this net that comes right back over here, and through a 10K resistor is hooked up to plus 5 volts. Now there's no current draw going into either enable 2 or enable 1, so really you should see both of those pins right at 5 volts right there. Okay, no big deal right there or anything to worry about. We're going to go through a list and double check all that. And this side of the chip is going to work exactly the same as this side of the chip. In fact, you can split a chip into quarters right here and look along here because you've got input 1 and output 1, input 2 and output 2, input 3 and output 3, input 4 and output 4. Middle pins are all going off to ground. Now, at the opposite corners of the chip, we've got the supply voltage right here. VS is going to be your motor battery power. So when you want to drive your motors, the power for that's going to come in from your 4 times AA battery pack and come right in here. There's going to be some transistors inside the chip so that when the input one goes low, that connects to the ground side of your motor battery. When your input 1 goes high, that connects output 1 to the positive side of your motor battery. So it's a fairly simple thing, just happening a couple of multiple times down there. Okay, so that's going to be going on right there. And we're going to take a look at ways that we can play with the Arduino pins right here and a few of our other pins on here to check and make sure that everything's working okay. All right. So let's see, I'm just going to minimize that. I've kind of broken this down into a little bit of a flow chart or things to look for. And anytime you're working on an electronics project, the first thing that you check, always check. A student brings you something and they're your best student who's never screwed up anything in the past, and they're like, this isn't working, I don't know why. Your own projects, okay? If they're not working, check your power supply first. Confirm that you've got the power that you need. The number of times that I've seen people jump into troubleshooting way down the line and get in over their head and then come back and go, oh, my batteries were dead. I had a battery in backwards. I forgot to turn the on switch on. My on switch wasn't working properly. All of these things happen, and if you don't double check for your battery, if you don't double check for your power, then you've got a problem. Now we've got some power LEDs on the board, so that's intended to make the most egregious problems obvious, but we're going to take a look at power. So anytime you're troubleshooting, start by looking for the power. I'm going to break this rule in just a moment, but it's a good place to start. Okay, and you're going to check power at your batteries or at your power supply, and then we're going to check on the board from a couple of different places to make sure that we've got both our motor power, because we've got a 4 times AA battery pack on here, so we've got 2 streams of power. Then we've got our 9-volt battery that comes in and goes through a 5-volt regulator on the Arduino, okay, so that we should have 5 volts running through our board. And so we should be able to check that, but we're going to check the voltages on the board for both of those. Then we're going to take a look at our logic in here to make sure that we're getting the right inputs to the L293D. We're going to take a look at the right outputs, and the outputs are coming down here to these header pins that are right on the back, okay, right in here. We're going to check and make sure those have the correct voltages going to them. And then finally, we're going to check and make sure that our motors run. And in fact, in this case, because we're separating things out and where I've seen the problems occurring, let's check to make sure that the motors are going to be running okay first. Now, the motors are a separate and independent system that should be able to work on their own. Okay, they don't need all of this stuff in order to work. They need this stuff in order to have everything be nice and controlled, but if you come along here and just take a couple little 22 gauge solid core wires, the type that we use for breadboarding, and stuff them in to the end of this little connector right here that comes off your motor, then you should be able to take those and plug them somewhere into your board here. And let's just go directly to the batteries. And I'm going to put one on one battery terminal and one on a battery terminal down on the other side. And there you go. I don't know if you can hear it and see it, but that motor starts to turn when I directly connect them into the batteries. So that is a thing you can do for each of your motors. You might be able to get one of those wires to plug into the spring clips right there. And there we go. When I touch that onto the battery terminals. Now, don't touch the two battery terminals right next to each other. I mean, you can if you want, but don't expect anything to happen, because if you look at your battery pack, this battery terminal and this battery terminal are connected to each other. Connect somewhere else down under the circuit, and anywhere in there, you should be doing just fine with two wires connected in right here. Oh, geez, didn't want that to take off on me there. Okay, so you can do that for each of your motors, and what that will confirm is that when this is plugged in to these little pins right down here on your board, that you can expect your motor to work. If that doesn't work, then you know you've got a problem between right here, and it doesn't matter what you do on your board, doesn't matter what you do with your Arduino code, it's just not going to work. Now, if that is causing you grief, one of the most common problems is that right in here, you've got a bad crimp. Okay, now that can happen a couple of times with these MTA 100 connectors. Sometimes somebody can use the wrong size connector. They'll say, ooh, I like the pretty blue ones. And they'll use a blue one because they like the color blue rather than paying attention to the gauge of their wires. Okay, in your kits, at least in the 2021 year, I may have given you a 20 gauge wire and a 22 gauge connector. Now that's not so bad because it's a bigger wire than the connector. So when you cram it in, then it should fit. But if if you're not seeing these push down nicely and you're not seeing your motors run reliably when you hook them up directly to power, you could hook them up directly to the power supply that you built earlier this year. What you can do is you can take that out and find a nice firm, sturdy surface to rest that on. And let's see, it's a little awkward to do once they're built into your robot. Maybe flip your robot over and then hold those up like that. And you need to hold them fairly sturdy. And then take a small flat-bladed screwdriver and just press down right on there. And you can press those in maybe a little bit further. Okay, so if those aren't seated properly, then your motor's not going to work properly. And if your motor's not working properly, it doesn't matter what you do on the Arduino. All the rest of the things are not going to work. So step number one, check and make sure that you've got motors that are going to work. Okay, like I said, I broke my rule of not immediately checking the power supply first. So if that's not what's causing you grief, I jumped to that one because I've seen that problem happen to a few machines. And it's such a quick and simple check. And it tells you that your motors are good, your solder joints down here onto the motor are good, that your wires are good. Sometimes you can actually, very rare, but certainly with solid core wire, you can have a break inside a wire. It's a rare thing, but if you don't start breaking your problem down into smaller chunks, you will never discover that. Okay, small chunk testing, one thing at a time. And now I know this motor's good, and so I'll also pop this motor off and do the exact same test to that motor so that I know both my motors are working well. Well, let's say that both my motors are working well. Then we've got a problem occurring somewhere else on the board. And that means things start to get a little bit fussier. Now, if you've got complex code running on your Arduino and you're trying to run a pattern, that's going to be a little bit more difficult for testing. So let's put some really simple code onto your Arduino. Okay, and let me drag this window over here so you can see what I'm going to do. And I'm only going to look at one motor to start with, okay? Simplify it down, and I'm going to take pins 3 and 5 because they control the motor on one side of the board, and I'm going to drop that code on there. But see, I'm doing it now. I'm getting too excited. I'm getting ahead of myself. What did I say to do first? Exactly. Check the power. Okay. Uh, and I'm sitting here saying, well, mine's working. I know the power's good. So, but let's go in there and let's check the power and see how we do that. Now, I've got the DP Scope software up here and running. If you've got your own multimeter, hey, use a multimeter to do this. But in the DP Scope software, you've got a utility in here called DMM Display for digital multimeter display. And so you've got a digital multimeter hooked up on your board, and I'm going to take the readings off channel 1, and you just have to click run to get that to show up. And now mine's just floating around randomly because I haven't hooked it up to anything. Now, over here on your board, there's a few different places that you can hook in. I like to use these little probes because they clip on and stay clipped. And what you're looking for is something that's connected to ground. And one of the easiest places to find ground is on your capacitors. And the negative sides of the capacitors are all hooked into this big ground plane. It's one common ground for the entire board. So let's just hook in right there. And now I'm hooked up to ground. And then for the positive side of the board, the different capacitors are hooked up slightly differently. This one right here, the positive side, should be hooked up to your plus 9 volts. So this is one way to see if we're getting 9 volts to your board, if you can get in there and you can clip right onto that. Not quite. Okay. Darn it, I did too nice a job of soldering that in there. A little bit of gentle encouragement. We'll get that in there. And now I'm going to measure the voltage across this capacitor when I turn my logic power on. And let's see, I'm reading channel 1 DC mean. That should be more than 3.33 volts. Channel 1 is sitting at 2 volts. That capacitor right there, let's just take a look at that on the schematic. So keep your schematic nearby when you're testing these things, and then you can flip back and there's the schematic. Okay, here's our power supply comes in right there. That's C1, and C1 should be connected to our V in pin, and our V in pin should be coming off battery 2. So C1 should be showing us our full 9 volts there. Let's see. You've lost my, oh, look at that. When I turn that switch on, it goes up to 5 volts. When I turn that off, the capacitor's holding that voltage. I'm getting weird fluctuation in my lights here. Maybe I do have a power supply problem here. If I turn that battery off, everything goes low and the capacitor discharges, but when I turn it on, that should be coming up to 9 volts right there. Let's just take a look. Maybe there is a problem at the battery level. So if I take that off, pop that open, and here's my 9-volt battery down here, and we can just pop the 9-volt out, and let's take a look at my charge on my 9-volt battery. Ooh, okay, so 7.8, not all that great really. Um, Just for the sake of this, I'm going to say that I actually had a problem in there. 8 volts, well, 8 volts would be enough to run your robot, but this is a 9-volt battery, and if you're seeing this battery voltage start to drop off, then it's possible that your 9-volt battery is starting to die. Okay, so we'll keep this in the back of our head that something interesting is going on here. And let's plug this back in. And I'm not 100% happy with that voltage right there, but might be able to get by with 8 volts right there. Let's see, am I still showing a lower voltage up on here? Now the other thing I shouldn't be seeing, and I'm not sure why I am, is I shouldn't be seeing my motor voltage showing up on there. That 9-volt battery should not feed back into that system right there. So if you've only turned on the one switch, then there might be something weird happening right down here. Something I'll have to look into later on. If I turn that off, they both go off. What happens if I plug in to USB? I'm going to upload some code anyway. Where's my USB? Got that one hooked up there. There's USB connection. If I plug that into my Arduino there, I've only got that LED coming on, and that's what I should be seeing. And I just ran into probably my DP scope doesn't like the fact that I just hooked something up on there. Says it's not responding. Okay, not quite sure why the DP scope was complaining about that, but for right now, I'm just going to switch over and start using my regular multimeter because that way you can see the display right down here. Oh, now look at that. All of a sudden, that started turning on right in there. Wasn't expecting to see that. We should just see one LED turning on right here. Something interesting is happening there. And let's just check our voltage right across here. I hooked it up backwards, negative 4.3. That's a bit low. We should actually be seeing closer to 5 volts across there. So we're going to keep our eye out for that when we go through the rest of the board. We're not quite done checking our voltages. Before we go and do anything else, let's check our main drive battery voltage. Okay, and the main drive battery is right down here. And there's a couple of different voltages that you might see coming off of here. To pick up that voltage, a great place to check at these terminals is right here and right here. And I'm getting pretty much 6 volts off of there. So those are fresh drive batteries, okay? These are AA batteries, 1.5 volts each for alkaline, or about 1.2 for nickel metal hydride. So if you've got rechargeable batteries in there, a full charge on there might look more like 4.8 volts. But if you've got alkalines in there, then you're probably looking at 6 volts. Now, the other place that you're going to check for that voltage, let me get that slid right in there, is when you turn everything on, turn that switch on right there. That's okay if those two light up when that one turns on. But a good place to check for your motor voltage is going to be on the back of the board right in here. And let's just take a look at the schematic right here to see where that motor voltage comes in. Okay. Okay, so here is our motor battery, BAT1 right here, comes right up here to our switch, turns on right here. And this is why it's okay if the Arduino LED lights up, the logic voltage, because we do allow electricity to flow through this way. So if you've got a higher voltage motor battery, you can actually draw voltage off the motor battery to power your robot. Just run into some brownout problems sometimes if you don't have enough voltage or current coming from your main battery. Okay, let's take a look at some of the other places that goes. Now it backs. It comes down here and it comes back down this side of the board to a voltage divider and a little capacitor that comes in, and you can actually read that on pin A3. So your Arduino is actually capable of checking the voltage status of your motor battery while it's running. Then it also comes off over here. You can see where it goes to the motor power LED, and then it comes all the way down here to your L293D chip. But there's other places that we can check as well, because as you can see, as it comes along here, it splits off and it comes to two headers. And so you can check between H3 and ground, or between the middle pin on, oh, let me move this over a little bit more and up. There we go. So you there we go. No, we still can't quite see over there. Anyways, there's this connection right here, and you can see that it comes over to right here, and we've got the servo speaker, the middle pin on there. Well, if you look at the back of your board, you'll see that right down here, there's a 3-pin header that says servo speaker, and the middle pin of it right in here. I don't know if I can get close enough for you to see that with good light. The middle pin right in here. Thank you, Canon. That was helpful. The middle pin of this connector right down in here says plus MOT on it. And that's your motor voltage, and the pin right next to it is ground. So if your motor switch is turned on and you want to see is that power getting into your board, you can come in here and you can go right between ground and MOT, and there's your 5 volts right in there. So that's a positive sign that our voltage is getting there. And then finally, we can come up and we can take a look at our L293D to make sure that we're getting signal all the way up to our L293D chip. Take your ground pin, and a handy place to, well, there's lots of places that you can find ground on this board. One of the handy places is just this big silver connection at the back of the Arduino. That is connected to ground through the Arduino. And then for your motor voltage, you're going to see that it comes into your L293D chip on pin 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just take a look at that chip, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm trying to get this all onto one display. Make sure you got a solid connection to ground. And then check pin 10 right there. And make sure that you've got 5.3 or whatever your battery voltage is coming all the way through to there. So okay, we've got something a little bit weird with my 9-volt logic battery. That seems to go away a bit when I hook up to the computer. And if I've got the computer and the main battery voltage supplying my voltage, I should be able to check my logic voltage by coming across any 2 pins of C5 and now I'm up at 4.86 volts, which should be fine for driving my L293D chip. And if I need to know for sure, I can check a corner pin of that right in here. And I should see on the corner pins of the L293D should always be hooked up to power. Oh, this was my ground pin. It was sitting at the +5 pin, so I was measuring from +5 to +5. No wonder I didn't see anything. There we go. I've got my 4.86 volts for logic, which is close enough for the Arduino to run quite happily. Okay, So back to our little troubleshooting idea chart right in here. And we've come in here, we've checked basics. Do the power LEDs turn on? I check my voltage. I check my plus 5 volts to ground. I'm getting 4.86 in there, which is not too bad. I check my motor voltage over here. I'm getting almost 6 volts, so that's great for alkaline. If I had nickel metal hydride batteries, so long as I had more than 4 volts in there, I'd probably be happy. And now I'm going to start taking a look at, well, is everything coming in to the L293D properly? And since I'm going to check power first, the L293D, I'm actually just going to pop the Arduino right off of here. I don't need it to send signals. I want to be able to see the entire chip right here. I'm going to turn my logic voltage on, and oops, now I'm not getting anything. Oh, of course I won't get anything on the plus 5 volts coming through right there. I just want to check on here. Oh, I did that check already, where I check to make sure, find ground on here somewhere. The ground side of a capacitor will work just fine. It's the one that doesn't have the little plus icon, and I'm just checking to make sure that the motor power 5.7 volts is coming in here to pin 10. Now, when I touch on those pins, okay, let's see if I can get in a little bit closer. We want to check a couple of things. Okay, now I want to check both on the pad of the pin right down here, because when I check on the pad, that tells me whether power is getting through the circuit board. But I also want to come up here and check right on the top of the pin, right in here, because if I have a bad solder joint down here, then I should see that voltage. Then might see the voltage on the pad, but I might not see it come up all the way to the top of the pin right in here. So take a look for all that. Okay, let's pop our Arduino back on here. And now we should have some logic coming through there. And as a result, I saw some of those LEDs blink. Now, I don't want to deal with blinking LEDs when I'm troubleshooting. I love blinking LEDs, but I don't want to deal with them when I'm troubleshooting. So I'm going to put super simple code on here. Okay, don't mess around with anything. Just come in here and tell your computer, plug your Arduino in, and put super simple troubleshooting test code onto your Arduino where you're setting one pin high and one pin low, and remember to set them to be outputs. Okay, and let me make sure I've got the right port selected here and drop that onto your Arduino. Yes, it complains at me about a bunch of minor things. Okay, so I've uploaded my code, and it's telling me that my code is uploaded, and 5 is high and 3 is low. And I'm definitely seeing not what I expected in there. Okay, now if I set 5 high, 5 is this pin right in here. Okay, and 5 is going to come out right through here. It should come through this resistor and flow back here if, oh, 5 and 4 are hooked together. 3 comes down and does something else. 3 is used for one of the encoders. My bad, bad code. It's going to come through here, and you'll notice that that problem showed up immediately because the LEDs didn't turn on. So the LEDs are a great indicator of a quick visual guide to your troubleshooting. And then what I'm going to do is I'm going to come back and change that code, make sure that I've got it right this time around. 5, 4. I suppose I should have looked at the schematic before I wrote that code. There we go. And now we've got one of the LEDs turned on. So it's coming through right here. 5 is going high, 4 is going low. And now I want to take a look at what I'm getting at on input 1. Okay, so ground one pin, and it can be right here or on the ground side of one of the capacitors. And then you kind of have to reach down underneath, and we are looking for input one, which is pin two, which is tucked away down underneath here. And again, I want you to be able to see that scope display. Maybe I'll use a different ground. Here's a ground that I can kind of clip into. And if I reach down inside and put my probe gently onto pin 2. Okay, there we go. So I've got a logic signal coming in to pin 2, and then the corresponding output signal should be coming off of pin 3, 5.73 volts. That's my 4 times AA battery pack coming out on pin 3. Now, of course, 4, 5, and all that should be 0 volts because they're down at ground. And then if I come down this way, well, I've already checked. Okay, now I'm on pin 10, which is my 4 times AA. Then I've got an input coming in here from pin 4, which we set low, and therefore my output is also at low. That's all really good. Now, let's double check those solder connections by opening our board and taking a look at the motor connection right here on the back. Okay, and it's on this side, and when I check right across here, okay, I'm getting negative 5.6, which just means that I should put my probes on in a different direction if I want to see a positive. But the important thing is I'm seeing a voltage right across there. So that's troubleshooting one side of that chip, and that side of the chip is working. But it's important that you go in and you take a look at the inputs as well as the outputs. And then when you know that's working in that direction, okay, come over here and change your code so that 5 is now low and 4 is now high. Okay, to make sure that nothing's shorted out in here and only going to be working in one direction. Okay, and when that gets uploaded, you'll notice that our LED used to be the red one that's on. Now it's the blue one right in here. You might have different colors in here. That's perfectly fine, but it's the inside one, not the outside one, is working. And now when I come down and I check my terminals down here on the inside, on the back, whereas before I was seeing -5 when I hooked up this way. Now I'm seeing +5. So if I had a motor hooked up there, it would be turning in the opposite direction. And now when you see voltage across here, okay, and you've tested your motor, you can come in and you can hook your motor up on there and your motor should be turning. So test your motor, make sure it's good, put really simple code on your Arduino, okay, notice there's no flashing, no blinking coming along right in here. Test your power supply. I think I might have a bad 9-volt battery in there. It seems to be reading a little bit low. It's down at like 8 something. But you know, it seems to be enough to keep the board working, especially when I'm plugged in right here, because I can observe 5 volts across this capacitor right here, or this capacitor. I think I touched something I shouldn't have touched right there. No, I probably touched shorted this across a couple pins because I was looking at a screen instead of looking at what I was doing. But you can measure right on here, and I'm getting 5 volts across down there. So everything seems to be running fine on this board, which makes sense because my robot is actually working. But those are the steps that I go through for troubleshooting. And based on what I've seen with a lot of the problems that people have been having, doing that first little one where you just pop that connector off, put a couple of wire leads in there, connect them to your battery and see if your motor spins. There's been a lot of problems right around here in these connectors and people not getting them nice and inserted sturdily. Okay, so go through there and let me know what you're doing. Here's that sheet again where I kind of broke things down into things that we were going to check. Okay, so we broke it down into mechanical, okay, where we took our motors and we checked to make sure that our motors and our gearbox and our wheels were working. It is possible to have a problem inside your gearbox. You can have the motor spinning, but have a stripped pinion gear in here or a stripped gear inside your gearbox and your motor won't turn. So you can have a mechanical problem in there. You can have a problem with the wiring, bringing that back to its little connector right in here, and you can push those wires in a little bit tighter. You not likely to have a problem with these connections right here, but you can unplug your motors and you can check your voltage outputs at those two terminals. Okay, we checked for one motor. You now have to go back and check for the other motor to find out what's going on in there. Sometimes one will behave differently from the other. Uh, then we came in and we checked our logic. We super simplified our Arduino code. We got rid of any fancy drive routines or pulses forwards and backwards. Those are all really nice once you've got things working. Um, and of course, we spent some time checking our power supply. And so if you break it down into those different modules, make sure that you've got power. Make sure that you've got very simple code, okay, that you understand and know what it does, that you're able to put a multimeter onto terminals that you're able to see. You can use your DP scope, or as we found, if that's giving you grief, an inexpensive multimeter. Look up multimeters on sale for at Canadian Tire or somewhere, Lee's Electronics, even KMS carries them sometimes. Can probably get everything you need if you catch a good sale for 20, 25, 30 bucks. And there you go. You should be able to figure out what's wrong with your Boombot. Hopefully nothing, but there's some places to start the search. Good luck. Have fun. Looking forward to seeing it roll around.